Example 1. This is something I'm going to ask you a similar question on a quiz coming up, okay? Assessments coming up. Probably something like this. A farmer's got 4,000 meters of fencing, wants to enclose a rectangular plot that borders a straight river. That means there's only 3 sides. You see that picture at the bottom there? At the bottom, there's a river. So they only need 3 sides of fencing, all right? 4,000 meters total. All right, so the situation is that you only need 3 sides to use up that 4,000 meters of fencing. So the equation is going to be that one of the equations that's going to show up in this function is that if you add y plus 2x, that equals 4,000. All right? So what we can do, and that's one of the situations that we're going to have. We're going to have one equation for fencing. Then there's what I started to say earlier, there's usually 2 equations. And if you look at this equation, this problem right here, it's got 2 equations that you're concerned about. So what I want to point out is that we've got this fencing and the situation along a river. And I'm gonna move over to the iPad now, okay? We've got 4,000 meters of fencing. And we've got the situation where we've got 3 sides to be concerned about. And we want to find the maximum area, all right? So let's go over to my iPad. All right, so this is what we've got. We've got a river here, so you don't need fencing on this side. So we've got 2 sides and that are the same, the rectangular region, and the other 3rd side is a different length. So it turns out we've got 4,000 meters of fencing right now. So what x and what y will maximize that area? So the idea is one of the formulas we have is that 2x plus y is equal to the amount of fencing. Okay? Well, they tell us that there's 4th, and the second equation we're concerned about, that's fencing equation. The other one is, what's the maximum area? So we're trying to maximize area. So there is another equation, and that is x times y. There's our 2 equations. Typically, that's going to be the situation. You've got 2 equations and 2 variables. You're given one piece of information. You're told how much fencing there is. So you've got 2x plus y equals 4,000. Now, as a result, we've got to maximize this. So we're going to need to take the derivative of that function. But right now, it's got an x and a y in it. So if we can look at the function that we're given the value in, the 4,000, solve for y, substitute it in the other, then we'll have everything in terms of x and we can take the derivative of it. I hope you heard where that's coming from, okay? So the idea here is, I've got this function right here. I'm going to solve for y and substitute it in to the other equation. So that's what y is equal to. And now I have the other equation is going to be x times y is 4,000 minus 2x. That equals the area. Take a look at that. We had 2 equations to start with. One of them we were given a value for. That one we solved for one of the variables, stuck it in the other, substituted in, and now this thing is going to have just x's in it. And we can take the derivative of that, okay? So what we end up with is area equals, what is that, 2,000? So it's minus 2,000. Let's multiply it out just like I've got it written. So I get minus, I get 4,000x minus 2x squared, right? So that's our function in terms of x. Now I can take the derivative of it. Every problem you're going to get a function, take it in terms of one variable, take the derivative of it. A prime equals 4,000 minus 4x. Set it equal to 0. So we end up with 0 equals 4,000 minus 4x. Therefore, 4x equals 4,000. And x equals 1,000. So at x equals 1,000 is where it's going to happen. Sometimes you'll get through a problem and you'll reach that point and you say, I got the answer. No, you don't. That is just the length of one side. You got to remember the question is, it might have been, what's the maximum area? Okay? Maximize the area. What's the max area going to be? Well, we got to plug 1,000 in to figure out what y is. So we plug it back. We already solved for y right up here. So if we plug 1,000 in, we get y equals 4,000 minus 2 times 1,000 equals 4,000 minus 2,000 equals 2,000. So y equals 2,000. And therefore, the maximum area, the max area is going to be x times y. And that equals 2 and 6 zeros. And what were we talking about in the problem? Meters. So we've got 2 million meters squared is the answer. Max area equals that. And if it's asking you for the dimensions, then what the dimension in one direction equals 1,000 meters, and the other dimension is equal to 2,000 meters. All right? That's the general pattern. You're given a problem. Draw a picture. Figure out x and y, or whatever letters you're using. Get possibly 2 equations. Find the relationship between x and y, and if you're going to be given one of the values, that means you're given one of the equations, the situation is going to be your answer, and you're going to have to take the derivative of the other. You can't take the derivative of when it's got 2 variables in it, if you don't use implicit, but you've got to take the derivative. It needs to have all the same variables. So you go to the other one you were given the value for, calculate one of the variables, set it equal to 0, take and substitute it into the original area function in our case, and then you get a function in terms of x, which is right here, all in terms of x. Therefore, now we can take the derivative of it, get the derivative, set it equal to 0, solve for x. That's the pattern, okay? And on the quiz on Monday, I'm going to include a problem like this, 3-sided fencing, okay? So I'll let you give a heads up. Look at that problem, and I think there was one like that given in the text. And yeah, and make sure you take a shot at that. The one in the text, section 4.7, they go through and they draw a weird kind of diagram, okay? And they put a fence in the middle, okay? So the one that's coming in the text that that I ask you to do in sapling, it's got another 3rd fence here, okay? I'm looking at my diagram. It would have a 3rd fence, and that means you've got 3 x's. And it's not along a river, so you got 2 y's. So an equation for that, if this situation here would be possibly 2y plus 3x equals the amount of fencing you have. Okay, so that time you're solving it, it'll come into a little bit more challenge. You got to do a little bit more algebra. But if you subtract 3x and divide by 2, subtract 3x and divide by 2, you can solve for y, substitute it into your area function, and it's the same kind of concept, okay? So we'll talk about that in a little bit and try that problem. And if you got questions, we'll address that. We can address it later or on Monday, okay?